Thanks for attending our session, this late in the day. I know everybody's anxious to go out and have some beers, so we really appreciate the attendance, and hopefully we'll make it useful for you. This course is Advanced SQL Server on vSphere Techniques and Best Practices. My name is Scott Salyer. I run a team of business-critical app experts for VMware. This is I guess I'm in my 8th year. I started in May of 2007. This is my 7th VMworld. You might have seen some of my white papers. There's a best practices guide for SQL Server on VMware.com. I was the author of that, and I was the co-author of the Exchange Best Practices white paper on VMware.com. So I'll be speaking with Jeff Saztak, and I'll let him introduce himself.
Hey everyone, Jeff Saztak, VMware. I am in my 7th year, so I've been here 6.5 years. Not quite as decorated in the white paper space as my co-presenter, but I am the co-author of the SQL Server book with VMware Press. So I just want to thank everyone for coming this late in the day. I do realize we are the session probably between you and a bunch of beer, so we will try to make this as entertaining and as painless as possible.
Yes, we will. All right, and I'll say this up front. We tend to, both of us tend to do a lot of slides, and in some cases we'll skim over them. We do that so that you guys can have reference material afterwards. The slides are available on VMware.com, on VMworld.com, so please check those out and use them as reference materials. And like I said, we just put a lot on there for your information. So, all right, let's go through the agenda, and then we'll get started right away. There are no architecture slides in here. This is all technical. We'll start right away with storage, talk about data volume and protocol considerations and designing for performance. Networking, we'll talk about things like jumbo frames and tuning the SQL Server guest. Memory. Let me go back. A few slides on how ESXi does memory management. We'll talk about large pages in the host, large pages in the guest, things like that. For CPU, a few best practices and sizing considerations. Look very briefly at consolidating multiple workloads and how that might work out. And finally finish up with SQL Server availability. So I'm going to turn it over to Jeff, and he's going to cover storage and network for us. Thanks.
You're welcome. All right, so who here wonders, should I do VMDKs or RDMs? Who's still kind of going through that? All right. Of those people who have their hands up, how many of you are thinking about if that applies to SQL Server clusters or not? Okay, so we're going to try to make this as easy as possible. If you're running a SQL Server cluster and it is using shared disk, otherwise in SQL 2012, remember there's two types, AlwaysOn Availability Groups and FCI, or Failover Cluster Instance. If it is FCI, the answer is RDM. If you're using shared disk clustering, the answer is RDM. Right? But if you're not doing that, or you're using SQL 2012 AlwaysOn Availability Groups, you can use VMDKs. From a performance perspective, our performance engineers will say don't let performance be the reason you pick RDMs or VMDKs. We're at a point now with the speed and efficiencies in the hypervisor that is no longer a driving factor. There are some other ones. We named one, which is clustering. Another one could be the tools that are used to monitor and maintain the SAN environment. Right? Some customers have invested a lot of money in those tools, and they want to continue to use them to get deep inspection in the performance of those LUNs. And the other one might be your backup solution. So check with your backup vendors. Some may want the RDM for the way they do the backups. We just have some lists there of things to consider, right? You got your 256 LUN limit that's still going on. Just a note on the 62 terabyte VMDK size. Just because you can doesn't mean you should do big files. Always think about your SLAs, your RPOs, your RTOs. If I have a 60 terabyte file and my SLA is 30 minutes, what happens if you lose the file? Can you get it back? Because remember, it's about 15 minutes before you realize, uh-oh, I got to get it back. And can you copy that file over? So there's a lot of things to consider, but we do give you the capabilities to do it. Scott, anything to add? So VMDK lazy zeroing, or sometimes you may hear this referred to as the first write penalty. So when we write to a block, so if we look at a block of blocks on the disk, the first thing we do is we write a 0 to that block. And then we'll write the data. Okay. Well, in general workloads, not a big deal. But when we got a database that's going to just like dump a whole bunch of contiguous writes to a file, might be a problem. Might be a delay, some may call it, right? So one of the things you can do is you can eager zero thick that VMDK file ahead of time. And what that means is I'm going to write, when I deploy the VMDK file, I'm going to pre-zero that VMDK file so that when ESX goes to write to that block, the zero's been there, there's no write hit. Okay? So that's what we call eager zero thick. Just a couple things on this. It is very, very important you understand the VAAI capabilities of your array. Some arrays make what will do things like that first 0, they just drop it and ignore it. So you don't need the whole eager zero thick. You may be okay with just thick disks. Okay? So this is where you want to, the guidance and a lot of the stuff Scott and I talk about are lowest common denominators to get you to understand kind of some of the concepts, and this is where you're going to want to take your environment and dive a little bit deeper. This is one of those areas. Take and work with your storage array of vendors, understand the VAAI primitives that are supported based on your version of vSphere and the array, the firmware in the array, and go from there. The other thing, and this is what I just call I call this a so remember what you're doing if you're deploying these eager zero thick. So if you're building a SQL server and you do 100 gigs of eager zero thick VMDKs in the middle of the day, you know what that's called? An RGE, or resume generating event. Because you just sent 100 gigs worth of zeros down to the array in the middle of the day, right? I would hide under your desk because a SAN admin's coming after you with a bat. So this is how you do it. The top one is vSphere 5. It's, what you want to do is click thick provision eager zeroed. That will give you the eager zeroed thick if you're going to be doing it this way. Another option on the right-hand side is if you deployed the VMDK and you didn't remember if you did it or not, you can actually, when you're formatting, you can click the Perform Quick Format, because Windows itself will go down and touch every block and verify it's okay, thus forcing us to go do it. So that's a way to do it. But just something to remember is when you're looking inside the administrative console, if you do the one on your right, it may show up as thick or thin and not eager zeroed thick, and you may have done this. So just something to keep in mind if it might be a mismatch. For those that are still running vSphere 4, the way to do it is support clustering features such as fault tolerance. I know that's perfectly logical and makes great sense. But the reason for that is when you deploy a VM, when one of the requirements for fault tolerance is eager zero thick disks. So when you check this box, we eager zero thick the VMDKs, but we didn't actually configure fault tolerance. So if you're on one of the 4 versions, this is the way you do it. And I also highly recommend you read our support statement for vSphere 4. So block alignment. This is very important. You'll see the link there from Microsoft that talks about block alignment and depending on what you read, anywhere from a 30 to 50% performance hit. That MSDN article links and talks about the performance hits around SQL if you have misaligned blocks. Now, Windows Server 2008 is supposed to align automatically, and for the most part it does. Scott will talk about a couple instances here in a second about where, just to double check, but one of the rules we do is we try to say, hey, a customer's fallen down, scraped an elbow, right? Bumped an elbow, scraped a knee here. So let's just put it in here to prevent other customers from doing it. Once you figure out how to do it, and we show you how to do it here, this should take you maybe a minute, and it may save you a lot of pain going forward, especially when we're talking 30% performance difference. And so what's happening here is really, as we're writing I/O to the array, If it's not aligned, when we send an I/O to the last block, we have to resend that same I/O when we come and wrap around. So the array is sending the I/O twice. The one I/O it needs to send twice instead of once. A lot of the arrays, they're big, they're powerful. It can hide that up to a point. If you have a lot of this in your array, this is a very painful and could potentially be a very costly fix. Scott?
Yeah, my only input there, am I on? There we go. My only input there is that when you create a VM, typically you might clone it from another VM, or you may not add the data and log disks until later. That's where you need to check disk alignment, because if those disks weren't added at operating system installation, you may want to go back and make sure that they're aligned.
Cool. So vSCSI adapters, people like these? People using them? Yeah, good. So one of the reasons you want to use them is the vSCSI adapter. It will use less physical CPU resources than the native driver. Right? So one, I have more clock cycles to give back and distribute to other workloads. As of vSphere 5.0 Update 3, you can actually go in and tweak the queues within the vSCSI adapter. Right? So if you're running big monster SQL workloads where you're noticing my queues, right, need to be adjusted, you can actually do it. And here's the registry key how to do it. Just because we have it here, unless you know what you are doing, be careful. Scott, in all of the SQL servers that you've helped customers virtualize, how many customers have you been in a situation where we actually recommended they do this?
One.
And this is the same customer that I have.
Yeah, right.
It's a big, bad SQL server. So out of the box, vSCSI can do a lot, right? The bottom bullet point is very important, not currently supported for any type of Windows clustering configuration. So then you're just using the native Windows LSI. So NFS, right, supported for SQL Server, not supported by VMware for Windows clustering. In-guest iSCSI, supported for standalone and clustered, right? So, the big thing there is that bottom bullet point, separate out your NICs, right? So make sure you're segmenting your traffic. I know it sounds painfully obvious, but you would be very surprised. That's why it's on the list.
One thing to point out about in-guest iSCSI that many of you have already found out, I'm sure, is even if you're using RDMs with in-guest iSCSI, it is possible to vMotion. So not necessarily supported, but it is possible.
That was Scott Salyer. So storage. So an interesting stat that comes out of that's come out of VMware GSS is that over 80% of the tickets that are logged that are associated with performance, the resolution or the way they're categorized is storage misconfiguration. 80%. Some will say that's low. But the number one reason within that 80%, not enough spindles to support the workload type. I see some smiles and some nodding, and yeah. And so the real reason we see this happen is VMware has come up through this tier 2 environment and coming into a tier 1 environment, right? We're starting to get some of that, big fast gear associated with our VMware environments, but the whole time SQL and our databases have been sitting on this tier 1 high-end hardware. And what we saw is customers would tend to pick up their SQL servers out of this tier 1, infrastructure and move it into a tier 2 infrastructure. And we just saw that fall down quite a bit. So, really what you want to do here is just remember its performance, right? The things you learn in the physical world, from a sizing perspective, you want to carry over into the virtual world. So, a quick story that hopefully cement this for you is I was working with a customer where they have a VoIP system and it needed to take all the recordings and dump it into a database. And we sized it for 20,000 IOPS. And we did all the best practice calls. We talked about everything. They were good. right? We had the SAN team on the phone, the network team on the phone, the VMware admins on the phone. It was one big party. Well, get a call month, 2 months later saying, hey, Jeff, you know that VM that you helped us size for 20,000 IOPS? I said, yep. They're like, we ran a test and got 1,000 today. We're 19,000 short of where we need to be. Got real quiet. Right? The problem was the SAN team went and ordered a bunch of large 3 terabyte slow drives because they got a deal. When we got the right drives in the array, we actually did close to 30,000 IOPS. So this is where it's really important to understand the stack all the way from the top and to the bottom. And this is where we talk about it's not just capacity. It is performance as well.
Yeah, and real quick there, infrastructure guys, you know, I'm going to speak on behalf of the DBA here. Standardization is mostly good, but isn't always good. So when you're trying to standardize on LUN sizes and you've got small, medium, and large, and you want to keep everything within, you know, a set of parameters that you set on the storage side, the application admin is going to need an exact number for I/O, especially for the Tier 1 databases. So listen to your DBA. When they say they need 20,000 IOPS, they need 20,000 IOPS. And giving them anything less is just going to hurt performance.
Yeah, and it's IOPS and throughput, right? It's both. So just if anyone can figure out how they actually did this, I would be willing to sit down and have you whiteboard it for me, because to me that just defies physics. So, Cheech and Chong, is that what you said? Someone's going to have a good time at the party tonight, huh? Yeah, I guess that's what Cheech and Chong would call a workload, wouldn't they? So it's important to understand your workload type. Databases have different workload types, right? So we've got our OLTP batch or extract transact load, and then we've got our DSS or decision systems, right? Which the bottom one, that's your data warehouses, right? And they all have different I/O characteristics, I should say. We listed them out there, and here's another slide where we talk about the characteristics, kind of what they look like in a little more detail for you. So, hey, Scott, they're taking pictures. Should we get in it?
No.
Okay. So I have this saying that I say, check it before you wreck it. And when you're working with your DBAs and they tell you, here's the type of workload we need to sustain, one of the things you can do is you can take a tool like Iometer or SQL IOSIM, and you can input these variables down here and test the disk subsystem to see if you architected that virtual machine to give them the throughput and the workload you need before you give it to them. Now you're handing that DBA a VM where they said, hey, I need 10,000 IOPS. I'm handing them a VM where I actually did an Iometer test and I showed that I could do 15,000. So when they call you and say it's slow, you can say, sorry, it's not me, it's you. Or maybe it's the developer's code, but we all know that couldn't be the possibility, right? So understand LUN size, right? The ESXi can do twice as much throughput just by the way it's architected, right? Understand where your potential bottlenecks can be, right? In this diagram, right? If I'm starting to push a bunch of I/O and I've only got one straw, right? That straw is going to fill up further than if I have 2 or 3 straws. And it's also the size of those straws. So as you start to build these VMs, and especially as you start to put a lot of SQL or a lot of high I/O systems on your ESX hosts, don't forget about architecting and the physical infrastructure. Right? While we can bend the rules of physics in VMware, we're still bound by certain things like HBA and the throughput on that. So the next couple slides we're going to go through kind of fast because some of these are summary slides. We'll pull up in some of the highlights for you. But what we want to really do is this will be reference material for you as you look at this deck in a week or so. Now, Scott, if there's anything you want to call out here on this particular slide.
One thing that we often mention for Tier 1 workloads, and we're not talking about the run-of-the-mill 90% of the SQL servers out there that are departmental databases. We're talking about the Tier 1 SQL Server instances. You know, create dedicated data stores to service those workloads. Make sure that they have as much in terms of storage I/O as they can get. Make sure that you load balance your workloads across as many disk spindles as possible. Make sure that you optimize your network if you're using network-based storage. That's kind of the gist of this slide.
Great. Performance best practices, right? We talked earlier about understanding what your storage vendor, there's lots of different storage vendors out there. Even within the vendors, within the different offerings they have, their recommendations may differ, right? So this is where you want to bring the VMware team, the storage vendor team in, work with them, right? We're here to help you. The storage vendor wants you to succeed too. So we talk about the VMDK files, we talked about those, and we talk about the same as physical.
Multiple vSCSI.
So we want to talk about multiple PV-SCSI adapters as well, right? So here's your VCP question of the day. How many PV-SCSI adapters can I put inside a VM? 4, exactly. So and this is again where Scott talked about, right, understand your database, and I'm not going to do this for a small database, but for my large, big databases, I can do 4 PV-SCSI adapters. Well, why would I do that? Each time I add a PV-SCSI adapter, I have the ability, I'm giving Windows another path and another set of queues in which I can queue up data and put it on the wire and send it out to the frame. Why is that good? Because now I can blame the SAN team, right? So that's the whole idea, right? I'm getting I/O off the Windows VM, right? Windows has more opportunity to take the SQL I/O, get it onto the wire, and I'm also fanning it out more, right?
Quick question. Can you change the queue depth of those adapters?
Yes, you can. Yeah. No problem, James.
Can you change them from regular SCSI to
PVs, so when you're going through and you're adding the adapters, right, that's where you want to say PV-SCSI. So, yeah, PV-SCSI, yeah. So the other thing you want to do too is understand, right, and what's a little bit different in virtualization is when all the I/O hits the hypervisor, all that sequential and random becomes, when it hits the array, what? Random, good. So something to consider is when you're laying this out, how are you going to stripe your VMDKs, right? If the VMDK is associated to the Windows OS or the binaries, or is it, this is where my database is going to be, or this is where my tempDB or my log volumes, right? Think about how you lay that out. There's 2 options there, both are valid, right? I can either put, all my temp down this one, all my logs down this one, all my data down this one. But sometimes when you're doing it with like that, you may get 2 PV-SCSI adapters that start to run hot and the other 2 are kind of warm because we don't see a lot of I/O going to the OS. Another option, option B, could be to balance those across, right? So just as you add them, stripe it, because now I'm fanning the I/O out and my PV-SCSI adapters are fanning themselves out, and since the I/O when it hits the array anyway is random, different guidance in the physical world, but just something to consider when you're doing stuff in the virtual world. That was your bonus for showing up, because that's not in the deck. We'll add it though. So, performance best practices, again, just another slide here. We talked about the queue depth. So the gentleman that asked James, right? Wow, how did I know his name? Here's the KV articles at the bottom for what you need. Again, another slide of just things to think about as you go through.
This is In-guest. Do you want me to cover this, Jeff?
Yeah, absolutely, Scott.
Okay.
I would love for you to cover this.
So a couple things. We talked about sector alignment already. One thing as far as data files, definitely pre-allocate your data files so that you can avoid the autogrow function during peak processing time. And if you do use autogrow, tend toward the megabyte versus the percentage. The calculation takes less time. Make sure that you use multiple data files for data and tempDB. The best practice guideline for years has been 1 file per core. Now, there is some argument out there as to whether that's still needed or not, but there's still a pretty large camp that holds to the 1 file per core guideline. For database file placement priority, if you've got a tiered storage environment where you have different speeds of disk, your fastest disk should hold the transaction logs. Your second fastest should be tempDB. Your third fastest should be the data itself. Place your data and log files on separate ones. Be sure to perform routine maintenance with SQL Server, and we already talked about the last one. I need to scratch that for the next VMworld.
All right, sounds good. So putting it all together, this is really, again, just a summary of a lot of the things we talked about. I don't think there's anything here we haven't talked about yet. So
yep, we can move on.
In the interest of time, we will move on to the network. So jumbo frames. Jumbo frames are a good thing. We like them. If I'm putting myself in the seat of a database, right, and I think about how I want to move packets and how I want to move data, do I want to move them in something, right, the biggest possible container? Do I want to move dirt in a wheelbarrow, or do I want to move dirt in a dump truck? Right? That's kind of the analogy to think about here. The important thing is you must configure jumbo frames correctly, or you will actually hurt yourself because of something called fragmenting. So if we don't set this up correctly, what will happen is I'll have that dump truck come to a switch that may not be configured, and now I've got people taking that dump truck and putting dirt into wheelbarrows and carrying it the rest of the way to my storage array. The other thing is, we have some people out there that say don't do this because if a switch goes out and you replace it and somebody puts a new switch in, right, now all of a sudden 6 months later they may not remember to do it, and I'm causing fragmentation, and who gets the call? VMware and the storage array vendor. Well, to me that's a change control problem. That's not, that's what that is, right? That doesn't negate the reason I would do it. But it is important to also, and this came up in the last session, think about your use cases and how this is set up. Because we had one individual that came up to us and said, well, my developers are accessing the database directly. Well, that may not be a good use case because I may not go out and configure jumbo frames from everybody's desktop into my database server. So again, this is kind of what Scott and I talked about is kind of general guidance and then apply it to your environment. Okay.
So we set our MPU to 9,000, but the vendor was actually 8892, and so that caused all of this.
So for those who couldn't hear, thank you, sir. If you're doing between data centers, also check to see if your telco vendors are adding any overhead, because based on what the telco vendor did, they incurred some problems. So thank you. That was great. Inside SQL, you need to configure SQL to tell it to use jumbo frames. Here's where you use the 8192 rule. If you want to understand why that number instead of something like 9,000, there's an MSDN article by John Hicks that talks about the rationale behind setting it. For those that, sometimes we'll see some smaller SQL servers because who's installed an app in the last 12 months that hasn't needed a database? We got one, Scott.
All right.
So the idea here is sometimes we'll set up some small departmental SQL servers, and just to be efficient, we may do some file or print sharing off of that. If you do that, this is a way to help improve and give preference to the SQL server over some of those other services. But if you're just doing big SQL servers and you're not doing anything else, you don't need to worry about that second bullet point. If you're doing, for example, AlwaysOn Availability Groups, something to consider is when we do vMotion or we do storage DRS kicks off of vMotion, the SQL clustering services underneath they do a heartbeat. You'll see it's 5 heartbeats based on 1,000 milliseconds. If you set this up and you do a vMotion and it misses the heartbeat, it may trigger a false failover of the AlwaysOn Availability Group. So one of the things you can do is you can come in here and change this, right? This is where you want to understand your network, right? Understand what you need to set this at, and go from there. If you're doing cross subnets or between data centers, this is really where you want to start pulling the network team in to understand what is the latency, distances, all that stuff between, because what you may set for your environment may be different than what the person down the street sets. We do support the use of more than one NIC for vMotion as of vSphere 5.0. We recommend this, especially with database workloads. Right? This is all about getting as much of that information across the wire as possible, as fast as possible. Just know that it'll be one VM to the NIC, so we don't actually take a VM and split it out to NICs. But the idea there is this VM1 will go out, port, NIC 1 and 2 will go out, and so we can still get it faster. More simultaneous vMotion supported, all that. It's all good stuff. We talk about 4 NICs per host for redundancy, separate everything out, and then the recommendation here are these, if your NICs support these particular capabilities here that we list out, that'll give you the best performance. Anything else, Scott, on network? The second one we'll talk about, if you're doing any of the clustering, right, separate that out so you keep the, hey, I'm here traffic away from the actual workload traffic. Use the VMXNet3 para-virtualized adapters for increased performance. Same reason you do, right? Uses less physical CPU as well. It's more efficient. We talk about tuning, right? You can tune, right, to get the best possible performance, and then just watch for packet loss. Right. Memory? And I'll turn it over to Scott.
Thank you, sir.
You're welcome.
Okay.
You like that dramatic pause we just put in the middle of the presentation?
Okay, so just want to reiterate, this is not for every SQL server. This is for high-performance SQL servers. And I forgot to mention this in the last session, but this recommendation is actually for hosts that have VMs running on it that are nothing but SQL Server. Okay? So we recommend, to get the most performance out of those types of environments, to use ESXI large pages. Now, large pages are really interesting. Instead of using 4 kilobyte pages, they use 2 megabyte pages. And ESX gives preferential treatment to memory spaces that are written on those 2 megabyte pages. One specific example is ESX large pages never get swapped out. And they tend to get, like I said, the preferential treatment from the other 4 kilobyte pages. It increases performance by reducing cache misses, and really low overhead for each virtual machine. Now, large pages normally do not swap. This is directly from our KB article. It is easier and less or more cost effective for ESX to break up a large page than it is to swap it to disk. Another example of why you should use large pages for your critical SQL Server workloads. Now, swapping is bad.
Who didn't know that?
Anybody not know that? Yeah.
If you didn't, please leave the room now.
But we hear a lot of customers say, especially customers that are virtualizing business critical apps, well, we don't want ballooning. We don't want transparent page sharing. Those things are in place to prevent swapping, which is the absolute worst of the three. So swapping only happens when the host is trying to service more memory than it has, and page sharing and ballooning are insufficient to provide relief. So swapping can happen in 2 places, in the guest and at the host. The guest OS swapping, not a whole lot you can do about it. There's a few OS tweaks that you can put in place to minimize that. But at the ESX level, we can completely eliminate swapping. There's 2 ways to keep swapping from affecting your workload. Number 1, at the virtual machine, you can set a reservation to equal the configured size of the memory. That does a 0K swap file. Or at the host, you can make sure that you don't allocate more memory than you have available on the host in the first place. If there's no overcommitment, there's no swapping. So let's talk about transparent page sharing and ballooning for a minute. This is why you should never turn these off, even though performance will go down a little bit. Let's say when the balloon driver kicks in, it's always better than swapping. So transparent page sharing, what that does is it will allow memory pages that are identical to be shared and merged so that you can save on the amount of memory you're using overall. Ballooning, the way that works is there's a driver inside the OS, and let's say you're only using 50% of the memory available. That driver will inflate and return that other 50% back to other workloads that need it, again, to prevent the host from swapping. So always leave these on. And if you're not overcommitted in the first place, which is one of our main recommendations, you won't ever see ballooning anyway. Memory reservations. This is how we control a VM to make sure that that VM gets the resources it needs from a memory perspective. Now, we could say, again, at the host level, don't overcommit, but that's not always possible. Sometimes you have to overcommit your tier 2, tier 3 workloads, and you want to give resources to your tier 1 workloads. The way to do that is through a reservation. Set your reservation to equal the configured size of the VM, and that will end up with a zero swap file, and you'll get guaranteed memory for that VM. The other ones can be starved. The other ones could be swapping like crazy. That VM is going to be guaranteed the amount of memory that you specify.
Who here has been working with their DBAs, trying to get their DBAs to move into this shared environment? And the DBA is like, oh, it's shared. Well, here, right, we combine memory reservations with the recommendation around the CPU of one-to-one that Scott will talk to. And then I beg to ask, how much of it is still really shared?
Right. Yeah, and here's an example in the GUI. You set the reservation equal to the configured size, you get a 0K swap file. So memory allocated to a VM is determined by DRS shares and limits, the total memory of the host, any reservations that you've set for that VM, and the memory load of the host overall. So let's talk a little bit about NUMA and why that's important. So NUMA was designed to avoid a performance hit when several processors are trying to access the same memory space. So when they developed NUMA, they developed it so that each core will have a certain amount of memory assigned to it. Now that's great. It speeds up processing. It prevents, it prevents multiple processors from accessing the same memory space. But there is a cost to jumping across nodes. So if my process here is trying to access memory that's located down here, then that's called NUMA crosstalk, and that can be a performance penalty or performance hit. So with that intro, there are a couple things that we can do to sort of minimize the impact of that. Number one is the virtual NUMA interface in vSphere. It extends NUMA awareness to the guest OS, where the guest OS wouldn't know what the NUMA architecture was before. And SQL Server does a great job of recognizing the NUMA architecture and tuning itself around that. So make sure that you enable this. It's on by default for machines that are 8-core plus. For smaller VMs, you can set the numa.vcpu.min equals 4 setting to get NUMA set for those smaller VMs. CPU hot add will disable vNUMA. So those are two incompatible features. You don't want to use those two together. For wide virtual machines, what we mean by wide is when the virtual machine spans more than one NUMA node, we definitely want to confirm that this feature is on in order to get the best performance.
If it's not, vSphere will use what's called wide NUMA, and wide NUMA actually under the covers is doing node interleaving. While it's better than what we used to do, it's not as good as vNUMA. vNUMA is available as 5.1 or later.
Now the great thing about SQL Server is it automatically detects the NUMA architecture once you've turned it on. So a few best practices. Go ahead.
As long as your cores per socket is set to 1. And I think Scott has that on a slide here.
We got that right there.
Okay, I just want to make sure we highlight that.
If you're interested in deep dive on how the scheduler works, great white paper. It's dry, of course, and very technical, but it's a great white paper to read if you really want to know the ins and outs of the scheduler.
So when you're flying home tomorrow, print this out, try to read it, and you'll be asleep in a second.
Just like that.
Especially those red eyes, right?
So in general, you want to avoid remote NUMA access. So if I'm just going for speed, I want the fastest speed I can get out of a SQL server, then design it to where that server can fit in one NUMA node, both from a processor and a memory perspective. Now you can't always do that. Obviously, you need bigger and bigger VMs. So The best thing to do for wide VMs that span multiple NUMA nodes is set the virtual NUMA settings and align your VMs with physical NUMA boundaries. So for instance, if a NUMA node consists of what?
2 by 10.
Yeah, 2 by 10. If a NUMA node consists of 2 by 10, you're going to want to size, based on a multiple of the NUMA node. Right, and that's what I was looking for.
Either a multiple integer or a multiple divisor, or whatever the word is I'm looking for. It's late in the afternoon, right? There's some very specific guidance on that in our KBs and in our white papers that Scott referenced above.
Now, hyperthreading is interesting because by default, the ESX scheduler, if it needs another processor, it's not going to go to the hyperthread. It's actually going to go to another physical processor. So if you want to take advantage of hyperthreading and your workload can take advantage of using the same cache on a particular NUMA node, you can set the numa.vcpu.preferHT option, and that will switch the scheduler over from switching workloads to another physical processor versus a hyperthread. Now, one last bit here. If you're vMotioning, you want to move between hosts that have the same NUMA architecture to avoid a performance hit. The performance hit only lasts until your next reboot, but definitely keep that in mind. vMotion between hosts that have the same NUMA architecture.
And so, if we go back a slide, right, the number of, ever wonder when you're building a VMs in this core per socket, what number should I put in there, right? Ever wondering what that's all about? If you leave it to 1, which is the default, what happens is when the VM boots or is powered on, we're going to look at the physical NUMA architecture underneath, and that's what we set as the NUMA architecture for the VM. When we shut down, we power back on, we'll check again. If you go and you change that, that is locked in, and that's what we will respect. So 5 years down the road, when you go to boot that SQL Server on new hardware and the NUMA architecture below it doesn't match, you may have a performance problem. Our recommendation is to leave it 1 at the default unless you have applications that will, right, based for licensing reasons, require you to do this. And then just keep that in mind with those applications.
Okay, so let's change to the guest. In the guest, we also recommend using large pages. Windows gives preferential treatment to large pages within the guest operating system. So the way we do that is we go into SQL Server Configuration Manager and set Start SQL with trace flag T834. One other piece is needed, though, and that is the lock pages in memory user right. And what this allows SQL Server to do is to grab that memory and hold on to it and lock those pages in memory so that Windows can't access those pages. Those are owned by SQL Server.
And just one thing to note, if you're not doing this and you turn it on, your VMs may take slightly longer to power on. Don't freak out, you didn't break anything. What's actually happening is when this is turned on, Windows is going to go and grab contiguous memory space inside the VM. Now obviously under the covers we're using pointers and stuff, but that's what the behavior inside the VM is happening. Now we're not saying if it used to take 5 minutes to boot, it's going to take 50 minutes to boot. This may be 5 to 7 type thing, but don't freak out, you didn't break anything, it's expected behavior.
It's kind of analogous to the page file in Windows. If you set it to automatic, it'll grow over time. Well, instead, if you set it to a fixed number, it'll allocate it all at boot. You're doing the same thing here with memory. You're allocating the pages at boot. So it may take a little more time to boot, but your actual processing of the workload is going to be a little bit better. So when you run multiple instances of SQL Server on the same VM, if you do nothing, the first instance that powers up is going to take all the memory, or the first couple of instances. And then the other instances that start up later on are going to be starved for memory. So the recommendation from Microsoft is to use one of 2 options, max server memory or min server memory. Now max server memory says, I'm going to let SQL grow to this point and then it can't have any more memory. The rest of it is reserved for other instances or for the operating system. The min server memory setting says that no matter what the operating system needs or no matter what other instances need, this server is, or this instance is guaranteed this minimum amount of memory. So you can use either one of these, and there are pros and cons to both. Now, if you're using max server memory, when a new processor instance starts, that memory is available right away. Now, the downside is if you have 5 instances on the host, for instance, and you shut down 4 of them, the 5th instance can't take advantage of the memory of the other 4 that are shut down because it has a max server memory setting. Now, if you flip it and go to min server memory, those running instances can leverage memory that's previously used by their VMs or other instances if you shut them down. However, when a new processor instance starts, those running instances will need to release memory down to the lower bound of the min server memory setting that you set. So option 1, option 2, it's debatable. Most people used option 1, wouldn't you say?
Overwhelmingly.
Okay.
Because the idea there, right? If Scott, we go back, would you rather, when you start a new instance, it be able to start? Or would you rather have, when you start a new instance, have to go in and remember to free up something?
Right.
I know which one I'm going to pick.
Exactly.
Single instance, max server memory makes more sense.
Yeah,
Yeah,
max server memory.
absolutely.
We think that's the best solution.
For both.
For most.
Yeah.
Yeah.
How much would you keep for the OS?
About 2 gigabytes is the recommendation, but it could vary depending on what you're running in the OS.
Can you repeat the question, please?
Yeah, absolutely. So the question was, this gentleman up here said if you're just running one instance of SQL Server, should I use min or max? He said he likes max, and we agree. The other gentleman asked when we're setting, what should the amount be set at for?
Yeah, how much should you reserve for the OS versus SQL Server? And the guideline is 2 gigabytes for the OS, roughly. And then everything else can be dedicated
And if
to
you
SQL.
have apps running on that SQL Server, that changes the calculation as well. So something to be, this is one of those things where you really got to understand what you're doing, because if you set this wrong, you can actually prevent SQL Server from booting, or your SQL service from starting.
That's very true. I read an article by a SharePoint administrator that had set min server memory to 0.
Yeah. Oops.
And it ran fine until he did a large file copy that took up a bunch of memory, and then SQL just couldn't start. So just something to consider.
My OS reservation based on NUMA Node. I made sure it sat inside of the NUMA Node.
Okay.
Just, those 2 probably would anyway.
Yeah. Yeah, so this gentleman says he does it so that his calculation, he does it so that it's aligned to the NUMA nodes. So,
Okay.
Seems logical.
yeah, that's actually pretty good.
Okay, so how many VMs can you put on a host?
So here, is this Scott's family or my family? I'm just kidding.
You didn't see me. So
I saw the pointing.
how many VMs can you fit on a host? As many whose active memory will fit in physical RAM, and leaving some room for memory spikes, basically. So active memory of the VMs plus any memory overhead plus page sharing of VM, or minus page sharing of VMs equals the amount of memory needed. So just a quick summary. Use large pages at the host level. Avoid host level swapping. You can either use, utilize the memory management features that we talked about. Don't overcommit, and if overcommitment's unavoidable, use reservations to protect important VMs. To avoid remote NUMA access, size your VM memory equal to or less than the memory per NUMA node. Use large pages in the guest. Do not use large pages in the guest if you're running another application on that VM. If the VM is dedicated to SQL Server, large pages are great. If you run SQL Server plus some other app, don't use large pages for the guest. Enable lock pages in memory to get large pages to work, and then use max server, min server memory to control multi-instance VMs. So a quick word on CPU. We only got 2 slides on CPU here. First, understand your workload. That's the most important thing. Understand average and peak utilization and allocate CPUs based on that. For tier 1 workloads, don't overcommit CPU at all or avoid it as much as possible. But for lower tier database workloads, monitor them over time and calculate how much overcommitment you can get away with without greatly impacting performance.
And this is really, you want to make sure you're doing like business cycle analysis, because we got those databases that sit there and do nothing for over 2.5 months, and all of a sudden they ramp up, and the last thing you want to do is do your analysis based on 1 month of data and cut a database off at its knees before it does its month-end processing.
Yeah, and we talked about NUMA node sizing. Same thing for processors as for memory. Let's see, what do we have here? This is all basically just summary stuff, so I'm going to move on to consolidating multiple workloads because we're running low on time. So consolidation options. Should I scale up, meaning have multiple instances in a VM? Should I scale out, which is 1 instance per VM? I'll tell you what the infrastructure administrators probably like. Option 2, the scale out. 1 database per VM. That's what most of us like. DBAs tend to like the other way because they don't want to manage so many operating system instances. So for patching reasons and that kind of thing. There are pros and cons, but in general, in a virtualized environment, it's typically better to go with the scale out approach in general. There might be a few instances where you scale up, but better manageability, faster migration via vMotion, better change management, more security. There are a lot of reasons to go with the scale-out approach. So I always thought this slide was really interesting because all SQL workloads are not the same. In this case, we're showing 2 different workloads that both say 15% average utilization. But the story is really told when you look at a time chart of how that server is being utilized. OLTP workloads tend to be dark at night and active during the day. And then you have batch workloads that tend to be active at night and dark during the day. These are great candidates for co-location. Put them on the same ESX host.
Yeah, if you guys needing Photoshop skills, call us.
You know what? I don't know why that didn't line up. But consider your workloads in the mix when you decide to stack SQL VMs on a particular host. And so that's what we just talked about. Consider workload characteristics. Manage your overcommitment as a function of typical utilization. Consider any operational history. Consider month-end, quarter-end, those types of scenarios where you're going to need extra processing. And DRS is kind of an insurance policy. You don't want to rely on it, but it can help balance workloads, if you incorrectly allocate resources. So we have like 5 minutes left, so a few words on availability. How many of you guys are using AlwaysOn? Availability groups, AlwaysOn Availability Groups. Okay, a few of you, yeah.
It's more than last year.
Yeah, it is. Yeah, it's starting to increase. And I think the reason it's starting to increase is because it's a better model for virtualization, for sure. But when you're designing a high availability system, consider all your options, but definitely at the business level, what are you trying to protect? And then even more so, what does the business care about protecting? We see so many of our customers that just cluster for the sake of clustering. And not all workloads need to be clustered. So make sure that you're protecting what needs to be protected. What are your RTO and RPO requirements? What's your SLA? Those are all things to consider before you even dive into the technology.
Right. So simple thing here is ask the business, right? Because if you're a DBA, I'm putting myself in the DBA shoes, and you ask me, do I want to go with the most highly available, get my butt out of jail technology? The answer is yes, right? I'm going to cluster. But if the business says, hey, I'm okay with 5 minutes to 7 minutes, the reboot of a VM based on the asset properties of a database, I'm okay with, crash consistent copies, right? Then the answer might be different, right? So get it from the business, because there may be CapEx, OpEx things that you can start driving value back to the business and reducing things like your cluster licensing costs. But we're also saying start at the top and understand, and then come down to a solution, and then map the right technology to that solution. We're not saying take everything off clustering. There are very valid reasons to cluster.
This is for continuity, but if anybody in the room doesn't know what vMotion, DRS, or HA are, talk to me afterwards.
Can I meet you at the Meet the Experts?
Yeah, Meet the Experts, right. Okay, so there really fundamentally are two types of clustering. There's shared disk and there's non-shared disk. Failover clustering is an example of shared disk. Non-shared disk is always-on availability groups or Exchange database availability groups. So our support stance is for shared disk configurations, we support it on vSphere with some additional considerations for storage protocol and disk configuration. In other words, you need to use RDMs is the example there. For non-shared disk clustering, we support it exactly just like physical. There is really no difference at all. If you're not using shared disk, there's no difference at all in clustering on vSphere versus clustering on physical. Now, shared disk clustering is basically a model where I've got one shared set of data and I've got an active passive node. One node fails, the other one picks it up. The way that works with vSphere, first of all, in order to enable this, we only support physical mode RDMs. So you can't use VMDKs, can't use virtual RDMs. vMotion, it will not work unless you use an In-guest iSCSI, and even then it's not really supported. But you can use vSphere HA. And vSphere HA benefits clustering by allowing the failed node to return to service faster than if you were on a physical server. Well, I lost that physical server and I wasn't virtualizing, I'd have to wait for HP to come or IBM to come to fix the server, or I'd have to slide in a new blade or whatever the case is to get that server back up and running. All the while I'm limping along on one cluster node. What happens if I have a second failure? HA reboots me in 2 minutes and I'm back up to full cluster operation. Now, if we look at non-shared disk, we don't have a shared disk component anymore. It's all over IP. And the one difference is it doubles your data, doubles the amount of storage you need, or potentially increases the amount of data by a factor of 16. I think you can have up to 16 replicas in AlwaysOn, right?
4, yeah, it all depends on the data.
Yeah.
4.
So, but it gives all the same benefits as failover clustering. Instantaneous failover, keeps your data intact, readable secondary, that sort of thing. So when you add vSphere HA with AlwaysOn, you get all the benefits of virtualization and all the benefits of clustering. You can use VMDKs, you don't have to worry about RDMs anymore. You protect against both hardware and software failure. You get the HA restoration of 2 minutes, 2 minutes or so to get that VM back up and running for full cluster operation. We do recommend, though, that you do anti-affinity rules for either type of clustering to make sure that those cluster nodes don't end up on the same host.
And especially if you're doing the FCI, the affinity rule is the must rule, right? Because in that case, we will fully respect it. And if you get down to a situation where we had to boot 2 VMs on the same host, we would not with the must rule. Right? A should rule is we will respect it up until we can no longer respect it, and then we will boot the VM. Yep. And the reason for that is just based on the configuration, the way you set up the FCI. If both of those VMs land on the same host, you're sharing data on the same SCSI bus. That could lead to a loss of data and a loss of your job. So that's why we want the must rule for that. So pay attention to that when you're looking at the configuration guides.
And we are so out of time, but we know you guys want technical content, so we shove as much of it as we can in here. So we're on the last slide here. Well, actually, one more slide after this. Within SQL Server, make sure that you use the cluster validation wizard. That's, and then patching non-cluster databases. You can actually patch a standalone SQL Server without clustering with this method that we developed, whereas we basically create a standby clone of the SQL Server, and then we move the data and logs over after we've done the upgrade. It's called rolling patch upgrade. If you go to our blog site, blogs.vmware.com/apps, you'll see exactly how we did this physically, and we've also created some VCO, vCenter Orchestrator scripts that will do this in about 30 seconds. You seriously just right-click and say rolling patch. 30 seconds later, you've patched. So that's basically it. Visit us on the web. Here's our Business Critical Apps site. There's our blog site. and buy Jeff's book. There it is.
Shameless plug.
Thanks, guys. Oh, I'm sorry, do we have a question?